Let's practice filtering. How do you select all flights from the year 1952? We import Pandas and create a small sample data frame. Import Pandas as PD. Sample_data equals year 1952, 1952, 1953. Month July, August, July. Passengers 150, 160, 170. df equals PD data frame, sample_data. We combine year and month, convert to date time. df date_str equals df year, .astype, str, plus dash plus df, month, .astype, str. df date equals PD to _datetime, df date_str, format equals %y%b. Running the cell now. This output shows rows filtered to include only data from the year 1952, demonstrating how to extract a subset based on a date condition. Notice the new date column combines year and month into a datetime object, enabling easy date-based filtering with .dt year. This highlights the lesson's focus on creating and manipulating datetime data for more precise selection. How about calculating the average number of passengers for July flights? We filter for July and calculate the average passengers. July_average equals df month equals a July passengers mean. Running the cell now. This output shows the average number of passengers in July, calculated by first filtering the dataset to include only July entries and then averaging the passengers column. Notice how the code isolates a specific month before applying the mean function, demonstrating how to extract targeted summary statistics from subsets of data. This approach is useful for analyzing trends or patterns within particular time frames. Try finding the best and worst months by average passengers in your own data. Real data often has dates in different formats. Let's see how Pandas handles them. We create a series with dates in different formats. Example_dates equals PD series, the 1st of March, 2022, the 1st of April, 2023, the 1st of May, 2023. We use PD to _datetime to parse them, letting Pandas auto-detect the format. Running the cell now. This output shows how PD to _datetime attempts to convert strings into datetime objects using default settings. Notice that only the first date string, formatted as a YYYYMMDD, is parsed correctly, while the others return NA because their formats don't match the default parsing rules when day_first equals false. This highlights the importance of specifying the correct format or parameters to handle diverse date formats properly. Let's sum up the total number of passengers in 1952. We filter for the year 1952 and sum the passengers column. Total_1952 equals df date .dt year equals 1952 passengers .sum. Running the cell now. This code filters the dataset to only include entries from the year 1952, then sums that passengers column for that year. The output, 310, shows the total number of passengers recorded in 1952. This demonstrates how to use date filtering and aggregation to extract meaningful summary statistics from a time series dataset. Now it's your turn. Enter a date string and see how Pandas parses it. We ask you to type a date in YYYYMMDD format. User_date_str equals input, type a date, YYYYMMDD. We import Pandas and convert your input to a date time. Import Pandas as PD. User_date equals PD to _datetime, user_date_str. Running the cell now. This output shows how the code converts a user-inputted date string into a Pandas timestamp object and then extracts the year, month, and day components. Notice that the input, the 15th of May, 2024, is parsed correctly, and the year, month, and day are printed separately, demonstrating how to handle and manipulate date data in Python. This reinforces the lesson's intent on working with date formats and accessing specific date attributes.